Hello. Tonight we're going to do an introduction to solving equations. I know you've done this in middle school, but would like to review some of the good practices you need to continue to do while following through in this class of algebra. First of all, to solve equations, you need to remember the order of operations. The order of operations is sometimes referred to as PEMDAS, or people remember it by saying, "Please excuse my dear Aunt Sally." The P stands for parentheses, which have to be done first. And then you do the E, which is exponents. M and D come together, they're multiplication and division, and you do whichever one comes first when reading from the left to the right. The same rule applies for the addition and subtraction part of the order of operations. Whichever one comes first is the one that you do first. Now, to solve equations, you need to remember that ultimately you're undoing everything that's been done. So you need to follow the order of operations in reverse order and undo the operations that are being done until you get the variable or the letter by itself. The steps to solving an equation, if you're doing the order of operations in reverse, include: first, you need to undo the addition and subtraction steps. Second, you would undo the multiplication and division steps. Third, undo any exponents. And lastly, you would undo the parentheses. Now later, I know we can use the distributive property to get rid of parentheses first. But up to this point, I'd like to show you the method where we actually leave the parentheses for last. Now, to undo an operation, you apply the inverse operation. You need to remember that the inverse of addition is subtraction. The inverse of multiplication is division, and vice versa. All right, here are some practice problems for us to do. And again, I'm going to do them step by step. I want to make sure that you follow the same rules that I do and also the notations that I make. So the first problem is 7x plus 9 equals 23. First step says get rid of addition and subtraction. So in this problem, they're adding 9. So I'm going to do the inverse operation, which is subtract 9. When I subtract 9, I need to do it to both sides. Now, when you're adding or subtracting, it's an operation that requires a straight line to show that you're performing that operation. So I have drawn a line underneath my operation. I have 7x left. 9 take away 9 is 0. So lots of teachers ask you to cross them out, and that's perfectly fine. Then 7x equals 23 minus 9 is 14. The second step says undo multiplication or division. Well, in this problem, they're multiplying the x by 7. So I'm going to do the inverse operation, which is divide. Notice when doing division, I draw fraction signs. I cannot draw one big line across because that denotes addition or subtraction. Make sure you follow these rules. 7 divided by 7 is 1. So I now am left with 1x. On the other side, 14 divided by 7 is 2. I know that this problem is done because the variable, the x, is all by itself. So the answer is x equals 2. If I wanted to check this, I would plug the 2 into the original problem, replacing the x, and making sure that my answer does equal the 23. For example 2, 5 minus 5x equals negative 20. Again, I see that the x is being multiplied by the negative 5. But the 5 out front is positive because there's no sign. So that means I need to do the opposite of adding. So I'm going to subtract 5 from both sides. drawing the line under it. The 5's cancel, and I'm left with negative 5x equals negative 20. Now the x is still being multiplied by negative 5, so I need to divide both sides by negative 5. In doing so, the negative 5's cross out, and I'm left with x equals a positive 4, since a negative divided by a negative is a positive. Next example, number 3. Negative 6 minus 7x equals 43. This time they're subtracting 6, so I'm going to add 6 to both sides. The 6's cross out because they add up to 0, and I'm left with negative 7x equals 49. My last step is to divide both sides by exactly what they're multiplying by. They're multiplying the x by a negative 7, so I'm going to divide both sides by a negative 7. X is now equal to negative 7. If I were taking a test, I would go back and check my answers. Number 4. I'm going to subtract 2 from both sides, and I'm left with 5x equals negative 25. Now I divide both sides by 5, and my final answer is x equals negative 5. Alright, my last two examples. Number 5, 4 parentheses z plus 5, close parentheses, equals negative 25. In this problem, the addition of 5 is happening inside the parentheses. And I know I have to do parentheses last, so I'm not going to subtract 5. What they're doing is they're multiplying the parentheses by 4. So to undo that, I'm going to divide both sides by 4. I'm going to be left with z plus 5 equals, now I can change this division problem to a decimal, but I prefer to leave it as a fraction. In this case, I am going to change it to the decimal, and we'll check into it more closely in class. So negative 25 divided by 4 is negative 6.25. Now the z is still not by itself. Now they're adding 5 to the z, so I'm going to subtract 5 from both sides. Now that z is by itself, I have my answer. Z is equal to negative 11.25. Now, although my answer is a decimal, I could still check it by plugging it into the z value. As long as both the left and the right side are equals, we know we have the right answer. The next problem, number 6, has parentheses again. So it's 1/4 parentheses p plus 8, close parentheses, equals 12. A fraction is just numbers. The top number is a multiplication problem, and the bottom is a division problem. So ultimately, they're dividing this set of parentheses by 4. So the opposite of division is multiplication. So I need to multiply both sides by 4. To denote multiplication, we put parentheses next to the problem with the number you want to multiply inside the parentheses. Multiply by 4 and divide by 4 are inverse operations, so they cross out. I'm now left with one set of parentheses with p plus 8 in it. Because there's only one set of parentheses with a 1 on the outside, I can drop the parentheses and I'm left with p plus 8. On the other side, I get 48. Last step, I'm going to subtract 8 from both sides, and my answer is p equals 40. Now there's two for you to try. The first one is 1 minus 5x equals negative 24. And the second one is 3 parentheses k minus 6 close parentheses equals negative 12. Please try both of these on your notes and bring them into class with you tomorrow. Have a good night.